So with that, I think it's time to start my talk about modern C++ package management using the Conan package manager. My name is Alex and I work for Hexagon. Hexagon is a global leader in software and in sensor products that allow you to empower an autonomous future by using technologies from fairly recent dates. We have a bunch of products that we sell and distribute to our customers, and I find myself in the surveying area where we provide the tools for the everyday work of surveyors. So some side facts about myself. I'm a software engineer at Leica Geosystems, which is now a part of Hexagon. Here you see my working email if you want to reach out to me, and on fairly all social media platforms and development platforms, I'm known as Stormbjörn Develops. So what will we hear in this talk? First, I will like to give some short motivation why I give this talk in the first place. Then some short introduction into those who are not too familiar with Conan yet. Then we will do a deep dive into the anatomy of a recipe of Conan, as well as we gonna hear some tips and tricks when with regards to using Conan as a tool. Finally, I will have a short Q&A session after the talk, so I would advise you to write the questions in the chat and I will be glad to answer them at the end. Thank you. So why am I giving this talk? First, we gotta know which goals we want to reach as C++ developers. In a nutshell, we want to deliver binaries that are suitable for a certain target or multiple targets. And we use various sources from different locations in order to get to those binaries, and we want to have it rather quickly. As well as, since we do not want to reinvent the wheel all over again, we want to utilize libraries and tools as much as possible to have an easier job. Which options do we have to accomplish this goal? I would see 3 options for now. If you know more, keep them for yourself or let the others know later. But I see the first one and the most popular one will be the pure sources. This means that you gather all the sources and then build based on these sources. Things that I would count into this section would be monoliths and Git submodules, as well as text that tells you where to find the sources. I am looking at repo and west as tools there respectively. The downside of this one would be that you have a high space requirement because you need all these sources in one place. Sorry, am I missing something? Am I too early? Thought not. Sorry. Sorry for the interruption. It's a bit distracting with these noises in the background. I'm not used to that. But like I said, you have a high space requirement, and because you need all these sources, you gotta compile them somehow, and this also takes a lot of time and is a bit contra-intuitive with the quickly goal. And after you have built it, you want to share it with other co-workers and other parties, which there's also no standardized way of doing it. So another option we might have would be the native package manager. The goal there is that we install packages that were pre-built already, and we just have them installed on our system and we can use them as we want. Examples for those would be the apt package manager for Debian and Ubuntu, Brew for macOS, and Chocolatey for Windows. The problem with those are that those are not really cross-platform, meaning that when you want to deliver a package specifically for macOS, you need to learn how Brew is doing its things. If you want to deploy to Windows, you need to know how Chocolatey is working. So you have a new learning curve basically for each native package manager. And what I also realized is that when you have such a package manager and you say you want to have something installed, the system and also the target in which this package is then installed on is basically the system on which you call install. But especially on embedded, you might have the desire to ship basically these compiled binaries onto something else. So that's where I would say the language package manager comes in. And the goal there is that you deliver your code simply as packages. Two vendors that are very popular and becoming very popular there would be VC package developed by Microsoft and Conan, that is a mixture of open source community and JFrog. I will look at the chat at the end if that's okay. It's too much disturbance. Feel free to add something, but I will not go to the chat if that doesn't bother. So the language package manager, there are popular ones for Python, Node.js, Rust, and Go, for example. Why should not C and C++ have one too? And the big strength there is that you can build stuff on demand and have a mixture basically out of pure sources and native package managers. The best of both worlds, so to say. So the benefits of it would be that you can build once and then have these builds shared with others. We will see later how I do that. Furthermore, it abstracts away these variants of building sources. So you have usually some utilities and do not really do the call to the compiler directly. And yeah, you have a various ways to do this, and the package manager says, I don't care how you do it, but it internally then calls the right tool for this job. Also, when you're developing proprietary sources as a company and you do not want to give the source code to everyone, you can still provide your packages in a binary form by just saying, yeah, you cannot, I omit yourself the ability to build it from source, but you can still use pre-built packages for that sake. And where the package manager really shines is when you have multiple workspaces, so multiple projects in multiple different directories, and they all have more or less the same dependencies. The package manager coordinates those dependencies, puts them into one place, and allows them to be reused over multiple projects that require the same dependencies. Also, the package maintainer, so the guy who writes the package, he's very familiar with the internal structure, how the source code is made up, how it is meant to be compiled using like one of the aforementioned variants of building. And you as a developer that depend on such a package, you only need to care about the API that the package maintainer delivers to you. Also, you yourself, you don't need to have the whole code base for those sources available, which means you have less space requirements and you're also faster with building it. So that's the motivation. Let's hop into short introduction, and I will start it with a disclaimer. So this talk is unfortunately not officially verified by Conan. It's mostly based on experience here at Leica. I've been working for Conan for about 10 months now, and yeah, it's nothing that is officially verified by them, just to keep that in mind. We also face a current transition from Conan 1.x to version 2.x, and stuff that is usually stable inside 1.x is going to be deprecated and also maybe removed, because for 2.x they have better plans on how to do things, and these things are currently considered experimental, although in the future they plan to be stable. Tips and tricks that are helpful for that I will present. These happen to be helpful for my case in my company, but I will always suggest you to evaluate up to your case and see if you really have the same needs as my company does. And last but not least, the documentation itself is always gonna be preferred over this talk, because this talk is something that I don't update very often, whereas documentation always tries to be updated. And yeah, in this talk I'm less focusing on consuming packages, but more on how to develop such packages, since it's a developer conference. So what is Conan? Conan is a free and open source package manager for the languages C and C++ that works on Windows, Linux, and Mac systems. In a nutshell, basically where Python runs, because Conan is built upon Python. It supports multiple build system and build script generators. Popular ones would be CMake and B2. And it is similar to Git in a way that it decentralizes where packages live in a decentralized client-server architecture. What do I mean by decentralized? So if we look at this image we have here in the middle, we have this Conan client. It's like a local executable that is running in some Python environment. And the developer and also the continuous integration, they interact with it with the same API that the Python program provides to you. Dependencies that are coming from the open source world, they are usually hosted on something called Conan Center. That's a platform that is yeah, maintained by JFrog and the open source community, and there you have a lot of package available at your sleeve. But as a company, especially when you write code that is not really open source, then it's strongly suggested to use Artifactory. Artifactory can be seen as a storage for recipes and packages, binary packages. Now, before we get lost in terms, here is a short slide to clear these up. So Artifactory, it's a service developed by JFrog used to hold private packages for either a team or a company or for yourselves. Also, package recipe. What do I mean by that? A package recipe, which we will see further in detail later, it's nothing but a Python class. And it represents like a set of instructions that you can use to get from sources to the final binary package. Then we have build machine and host machine. Both are computation units, and the build machine is the one that performs the building job. So taking sources, creating binaries out of it. That's the build machine. And the host machine is the one that is then taking these binaries and runs them. Also, we have the terms, some directories that are of importance. We have the include tiers. That's like the one that contains header files. You have lib tiers that contains libraries that you can link against or that you link your target against. And runtime dependencies, executables, those are then usually kept in the bin tiers. Also, we have this concept of locking, and that is just a snapshot of a current state, and it is kept to ensure reproducible builds, but just that we heard of it. So what does a Conan recipe actually consist of? So the goal there is that we have some sort of instructions to get from sources to a binary, just to recap that. Let's talk about versioning first. At the top, you can see basically the structure, how Conan has like a identifier for Conan, let's say. So a package itself can consist of a name and a version, as well as optionally some user and channel information. The revision part here, this is usually not done by the user, but this is what Conan usually adds upon export. So the name itself, like it's pretty self-explanatory. It's like the name as the library and the project that is packaged by this recipe. So in the sake of this example, I chose emBO lib. Then we have the version that can be really any string, but it's recommended usually to apply some semantic versioning on the version field. For the sake of this example, I went with 1.0.0. The company in this example would be the user field. This is helpful when you have multiple libraries with the same name and you want to distinguish between them. Let's say you have an open source library that comes from the user from open source, which would be the empty user, and you want to have a more proprietary version of this package, then you can add your company name into it and then it doesn't clash with the open source one. The channel is coming after the user and it describes how mature this package is. For open source packages, this is empty by default, but most often stable is the word that you will often find. The revision, like I said, it's something that Conan appends to the recipe, and it is basically some sort of identifier to really nail down which particular recipe you're referring to. Can be, for example, a hash of the content that's inside the package, or another example would be a git commit. How can we specify a version? So the version itself can be described as a field or as a method, and in there you can just like have a bunch of options that you can put in. Like I said, you can put in absolutely anything there, but since I already recommend semantic versioning, I try to stick with this one. But another option that you can do if you do not specify the version inside the Conan recipe, you can specify the version upon export at a later point in time. This is useful when you have one Conan recipe to target multiple versions. The usage, how can we use this version then afterwards? So what we see here on the left, we have a requirement, and this thing inside the requirement, this string literal here, this is how we then can refer to such a package. And the options there is the exact matching. So we basically say which version do we want. If we say we care only that a certain feature is present, and if somebody else wants to take a newer one, you can then use something that's called a version range. The example that I have here means basically that you have to have at least 8.1.1 satisfied, but it can also be 8.2 or 8.1.2. but it needs to be lower than the next major version. The last option that Conan gives you is that you can have aliases, meaning some package that is present for Conan. You can give it a more abstract name, and then people can refer to that using this name. In this example, we have specified an alias for format called format8.x, and we can use this one to refer to this particular version. Then the upside of this one is that you have in one place, you can have in one place basically a switch that allows you to change this line here or resolve to a different thing at some time in the future. Then after versioning is out of the way, we have build configuration items. What do I mean by that? So in general, we can split them here in half. You have the group of settings and you have the group of options. Settings are always mandatory in Conan, and the values that you can put into settings, those are specified in a file called settings.yaml. And since they are mandatory, you specify them once and they apply to all the packages inside a configuration. The options on the flip side, they are really specified inside the recipe itself. So for this example, the recipe says that it can be either a shared or static library, and it can have the position independent code feature active or not. But for options, it's important to know that you also gotta set defaults for it. Otherwise, Conan will be confused. And usually you put very package-specific stuff in there. Now that we have them defined, how do we use them? So first of all, we gotta know that build configuration items like settings and options, they Conan differs there between the build machine and the host machine. And you can overwrite these build configuration items. So for example, you have an accumulation of settings, options, for this case also environments, and you can put them all into one file and then refer to this one to be applied, which would be here this profile clang 10 would be applied. Then you have also the option to override them. So we specified here in this profile that the build type should be debug and the shared option for all libraries should be true. So if we want to override this, we can do so as we want. So we can say, no, even though the profile says debug, I still want to go with release. And for the shared case, I don't want sharing, I want static libraries. Just as an example. The options and settings that you specify, they will usually flow into something that's called the package ID. So the values that you see here, settings or compiler, build type, architecture, shared, and FPIC, they flow into something that's called a package ID, and it's basically an identifier computed from these values to correctly identify a package. And yeah, you can customize that if you want. Now we have basically the version and we have the configuration out of the way. Next, for our build, we will need sources at some point. So we have headers, some translation units, so C and C++ files, maybe some licenses, and files that support our package manager throughout the build. For example, a CMake list if we wanted to use CMake. What options do we have to gather these sources? Well, the most straightforward one is this one. If we have sources that are next to the recipe, we can export them with the recipe. So when the next guy demands the recipe and a build from sources, the sources will be there. And in this case, we just say, okay, I have it locally on my file system. For example, I have a include folder with files and a source folder with files and a CMake list, and I can copy them with this command. If we happen to have the sources inside a Git repo or some other version control system, there is also a way to download these on demand. So the source method is when you do not give the sources with the recipe, but you download them from external. This is an example on how you could do it. So you, in this case, it's using Git. So you say, in this folder, I want to have this repository being cloned. And then, yeah, Conan does it for you when it is time to build from sources. The SCM feature is one that you can use when you're lazy as me and you say it is in a, this recipe is under version control, the sources are next to it, but yeah, I want to do less typing, let's say. Then these auto fields for URL and revision, they will be resolved to the Git repo itself, so namely a string like this, and the commit in which state the sources shall be. With sources out of the way, we maybe also need dependencies that our sources might depend on. And here we can differentiate between software dependencies that are made for the host machine. You have test dependencies that may also run for the host machine. And you have tool dependencies that might be something that you will need for your build, but on the build machine. Furthermore, you will need generate files to locate these dependencies. Maybe a few words on that later. And when you deal with shared libraries, you also got to ensure that these libraries that are needed at runtime, and yes, I would consider a test as a runtime, then you have them also being imported. How does this look like? So we have requirements for software requirements that we need during the execution. In this case, I'm depending on the format library, some version, and it can also be a pre-release. This is how you would specify it. You can have build requirements, and there you, for example, gtest would be a good one for test requirements, meaning that the source code that I've built using this dependency might have some test cases, and well, I'm not shipping, it doesn't need gtest at runtime, but when I build it, I want to run the tests, and then this one could be coming in handy. And I also maybe use CMake and maybe also protobuf if I want to really go crazy. So with these dependencies specified, in my case, CMake needs to find them somehow. This is what the generate function does. The generate function usually has generate calls in them that uses some generator that is provided by Conan. In this case, the top one is capable of translating the settings and options into CMake variables, and the CMake depth generator is providing these locator scripts. So from CMake you can then say find package, my package, and you have the target there then. And for the runtime libraries, you have the dependencies at your sleeve and you can copy stuff from them. Building. So now we have sources and dependencies satisfied. Now it's time to finally build package binaries. Yeah, there we go. So Conan is very unspecific there. Usually it's best to let other tools that are dedicated for this job, let them do the job. So for my case, I have a CMake project. So In CMake, you have the configure, build, and test phase, and this is a good candidate to run during build. Of course, if you do not want to use CMake or happen to have other builds, build helpers, you can also call them like here below. So you can, there are a bunch of supported build helpers, but if none happens to be there, you can also go with a custom one or just like write the shell commands in here. Now that we have built it, we have it somewhere on the build folder, and we want to have it in a more cleaned up folder where we do not have the test executables and the runtime dependencies anymore, because that's not what we want to ship. What we want to ship in the end is only like the include headers, files to link against, and maybe some shared libraries, like here below. In my case, I have a small library that has 2 headers that are publicly available, that are meant to be used for consumption. And I have 1 target here statically linkable available. Yet again, also for the package phase, you can just go with simply copying stuff, or you can use another helper to do this job. This is maybe the most important function. So the layout function is one that describes at which phase of a package creation where to find stuff. What do I mean by this? So when we are done with the build and the packaging, this description here, for example, describes that at the package phase, you have these include directories, you have this target to link against, and the linking files are usually in lib, and the binary files, like the files are available for execution, they are in bin. And this layout function just gives some meta information for generators to know where stuff is. Also here Conan provides a function to provide a default layout for various build system types. And you can also customize it further. Now I think we're through with the package recipe. So with that, I would now hop into lessons learned that yeah, were achieved during my work with Conan. So the first thing that would be interesting to know is that we should strive towards a unified client setup. This means that profiles, so this accumulation of settings, options, and environment variables, and build requires and other stuff, that we share those with others, and that we do not need to re-specify them all over the place, because this can soon end up in a mess. And the config is such a place. In the config, you have profiles, you have a local Conan client configuration, you have this pool of available settings, and you also have the place where you want to store package recipes and binaries. And all of this is inside, or can be inside, one versioned SCM project that can be installed using the config install command. The fun part here is that the continuous integration and the developer have basically the same set of client setup, but it does not care about, it only has a different, sorry. Sorry about that. Where was I? So the difference between CI and developer shall only be that the CI has some additional tasks to do, and it maybe has some more permissions to accomplish this task. But in a nutshell, the Conan strives towards having developer and CI doing the same stuff. Next, now with that we have a config that everyone can use, we shall have recipes that everyone can use. For that, we have, maybe it makes sense to zoom in here. So we have the Conan class definition, let's say. So we have some fields and also some methods that make sense to be, oh, sorry, now is it better readable now? So we have some attributes and some methods that need to be specified, and yeah, with that you have a good recipe altogether and you can use it. So the goal that we should really keep in mind when designing these recipes and coding these recipes is that Conan should be able to build this package from gathering sources, performing the build step, packaging and redistributing it further. Conan should be able to do all of this automatically without the need of additional steps that are hidden, like avoid script calls after Conan has done its job. I also made, for the sake of this conference, I made a small project available on the public GitHub domain that you can use freely for that. The next tip that I want to cover is to make use of exporting recipes instead of building them right away. What I mean by that is that if we look at this graph here, you have maybe an executable that depends on a library. This library has another dependency to another library, and maybe also a build dependency to some testing framework. The question would be now, how many configurations do we need to build this library for if we want to say we want to provide general precompiled binaries for this particular library? The answer to this is you cannot know, because there are configurations that currently exist that may be a few thousand, and if you then happen to have a new platform, you can have a permutation of all these 1,000 packages. So it's not really something that is countable or measurable. And for this reason, if we just happen to have this graph, and by the previous tips and tricks, we promise basically that Conan can build a package from scratch to the final binary. We can ensure that Conan allows us to take this topmost node and follow these arrows up until the very last point to build those on demand. This can be done with the build missing, or there's also a newer one, the build outdated flag. So for my example, if I happen to have an executable that is using my library, and the library indicated in gray has never been built before, I can use these flags to build them all in one iteration. After that, packages were built. You might have a second iteration for another executable. Note that it happens to have the same configuration being used. So what you need to build at the end of the day from the whole package graph that this application uses, only the packages that were not built before. Since we built these packages already with this guy up here, we can reuse them and have them available already. Let's stick to this graph for a moment. So let's say we're a developer of this library here, and we are doing a very new library that nobody has ever used before. So let's assume these nodes here, they are not there. Or maybe somebody is using your library already and you're not aware of it because you're in this narrow focus here. How can we test this package? Well, there are two sorts of testing. You can run unit tests. Those I would usually treat them as sources, and you can run them when you are building it. And the other one would be like the test that simulates the guy that is using your package at the end of the day. I will call it the API consumer test. The API consumer test is done inside something that's called a test package. It's a simple translation unit and a simple recipe that just has an automatic dependency to your currently developed package. And it installs this dependency inside this test package context and has it available for use. What are good benefits of this one? So first of all, if you are the maintainer of this guy and you also specify this guy, you first of all see when breaking API changes would happen. So if you unintentionally break the API on this level, this package is the first one that would notice and would cause the build to fail. Also, if people are too lazy to read your documentation of your library or the documentation is not in a very mature state, you have the test package available and people can go to these test package sources to see how you as a library maintainer intend to use this library. Also, like I said, when you have no consumers yet, it's easy to test your library against a fake consumer to have a bit of isolation during development. So now we have a good recipe and we have a test package and all that good stuff. Now your boss comes to you and says, well, you're having this code now, but how can I ensure that this graph that advances over time, how can I ensure that the build that I happened to do 3 years ago is still valid up until today? How can I do that even though the dependencies inside these packages might advance and change over time? The answer to this that you can give your boss will be log files. A log is, like I said, it's a freeze of this graph like we've seen it before. And you just freeze it in place, and this place happens to be a text file that you just like store somewhere, and from this text file you can then install the package, build as if it's needed, and install it somewhere where you want it to. Here a good hint would be that you should, when you release, if you're satisfied with your package graph and your product works fine and you want to release it, please also keep in mind that you somehow need to persist these log files to ensure reproducibility for later. Then I will have a short section also around debug symbols. So if we build from sources, debug symbols are usually just some mapping from the binary to these sources. But when we install a pre-built package, these sources are usually not there. And from that perspective, it also does not need to make sense. It doesn't make sense to provide these symbols. But, here a big but, you can build those symbols on demand from source, because any package that you have in a graph, you can say, I want to build it from source, and then you get the debug symbols. Yeah, one of the few remaining topics would be editables. So when you are developing code that is inside this library or the recipe itself, you might want to make use of editables because the whole workflow of gathering sources, building, packaging, and all that can be very time consuming when you do it repetitive. So one semicolon edit and then do the whole thing again. It's very inefficient and therefore you can use editables. In a nutshell, it works like this, that you install the dependencies of the project that you're working on. You activate the editable mode, and once it is in this editable mode, the build output folder that is done in this step is basically used as a source for the dependency, like for future dependencies to look into. So when you have a consumer that depends on your currently developed package, it will look inside your particular build folder instead of in the cache. And well, once you're done with it, you can just deactivate the editable mode, and from there on, it's like a normal package again. And here I would really suggest you to look into the official documentation because this one is currently actively under development and there is no stable, or I could not find a really stable way to do it with both the old and the new way of these packages. Last but not least, you have the open source packages available. Like I said, there are about 1,200 of them that are available in Conan Center. And of course, if you have open source library that is not there yet, you can also contribute to it. So wrapping this talk up, I will just want to mention that Conan also has a cheat sheet in its documentation that allows you to have a better overview of commands that you can use for your everyday use with Conan. So without that, with that said, I would like to thank you for your attention and will be happy to answer the Q&A questions now if we have some time remaining. So let's see. Okay, there happened to some stuff. Okay, where shall I start? Schedule got updated. You can mute them, don't look at the chat. Okay. So here, question was, what is VEST? Slide 8. So when you build from sources, these manifests, they are text files that tell you where sources are, basically. And VEST is a tool that takes such a manifest. It happens to be the main build tool for Zephyr, and it is taking this manifest to prepare your sources in a way that is convenient to work with. Same goes for the repo tool. Repo is one that is used for mostly on Yocto Linux. GitLab also supports Conan packages. Conan recommended for quite some time now to use Artifactory instead. Well, Artifactory is like a solution that you can use to host your packages on your own with your own code and without open source, and Conan just does not maintain those. So I don't think they necessarily do not recommend to use the open source libraries, but Artifactory is something that you as a company want to host yourself just to be quicker. And yeah, what I did. Okay, I think okay, so last question from David. So the tests of the test package are run on demand in quotes, with the settings and options requested by the client. Yes, that's correct. So when you build a package, you have the option to run the test package also. And with that, you can, you gotta specify for which settings and options you want to use it. Okay. I think for the remaining questions, it would make sense to yeah, hit me up after the talk, if that's okay. Okay, then thanks a lot, and have a good day and a few good remaining hours. I will be in the right top corner for further questions. Thank you.